Hey guys, we're going to do homework for 6-2. Let's do it. Okay. So using some of our notes and just kind of logic, when I go to draw something, it's like, oh, I noticed that this is always true. Okay, so the first one says, use the parallelogram to decide if each statement is true or false. Okay. So if I look back on my notes, here's all the things that we know about a parallelogram, right? So let's think this through, right? Opposite sides are congruent. So this side's equal to this side, the same length. Those lengths, those are the longer lengths. So opposite sides are congruent. Opposite angles are congruent. So this angle that's obtuse matches that obtuse. And this acute angle matches this acute angle. Consecutive angles are supplementary. So if I took a protractor and this was 130, that means this would be 50. The acute one is 50. And so that's what that would mean. So if I work consecutive means next to. So this one plus this one is 180, right? And this one plus this one is also 180. And this one plus this one is also 180. That's what that one means. Okay. Diagonals bisect each other. All right. So if I drew a diagonal, I'm going to draw a nice thick diagonal here. All right. There's a diagonal. There's a diagonal. They bisect each other. So this length is equal to that. Oh, it's too fat of a line. This length, this one right here, here to here, is equal to this length from here to there. And this length, 1, 2, 3, 4, is equal to this length, 1, 2, 3, 4. Does that make sense? Okay, so using this information, we tackle this. It says BCA, so this angle is equal to 35 degrees. Would that be true? Well, it is a parallelogram, right? So if you see a Z that spells AIAT, opposite interior angles are congruent. So that's actually from a previous chapter. We know that'd be 35, true. Would CD be 5? Well, I'm going to say false. Opposite sides are congruent. So this would be 5. AD is opposite BC. What about, is BD perpendicular to CA? So is BD perpendicular to CA? Well, it kind of looks like it, but I can't go by looks like. So going back to my notes here, notice right here, it's very obvious that's not 90. In fact, that's quite a bit bigger than 90 degrees. So, and there's nothing here that says diagonals are perpendicular. In fact, it does say in a kite that diagonals are perpendicular. So apparently that's not a thing for parallelograms. So we're going to say false. Almost said true. Okay. Is the measure of ABC 110? Okay, so that gets to our notes. AB, is this 110? So let's take a look. Consecutive angles add up to 180. So if that's 110 and this is 35 and 40, so that'd be 75. Does that add up to 180? I'm going to say no. 110 and 75 add up to 185. So I'm going to say no. That can't be 110. So let's figure out what it would be. 180 minus 75 would be 105. Okay. Is BE congruent to ED? Is BE congruent to ED? That I can say yes, right? That came from our notes. This length is congruent to this length because diagonals bisect each other. Okay. Question number 2. The length of PR and QS. So PR and QS. Determine their lengths. Okay. So what do we know? Well, we know the red line was cut in half at T. So this length is equal to that length. What else do we know? We know this length is equal to this length. The blue line was also cut in half. So let's take a look here. The two red, QT has to equal TS. So 2y plus 3 is equal to 3x plus 2. All right, what's happening? That's my red one. And what's happening with my blue one? Well, it looks like PT has to equal TR. So they're making this an algebra problem, aren't they? Isn't that interesting? So let's see, what would be the easiest way to do this? I think most students are probably most comfortable with substitution. So I'm going to solve for one of the variables and then substitute it back in over there. So, okay, so I'm going to add 1 on both sides. And then I'm going to divide everything by 2. Everything on the left, everything on the right. Okay, so now I know y is equal to this stuff. And where I see the y, I can substitute that back in over there. So 2 times 1x plus 1. Again, I substituted where I saw the y. That's where I put that stuff because y is equal to that stuff. And then I'm going to add 3 and 3x plus 2. Okay. So now I can clean this up and figure out what is x and what is y. I've got 2 times 1x is 2x, plus 2 times 1 is 2. And copy the rest of the problem. Okay. Oh, I copied that down wrong. All right, now it's starting to look like a problem we've been working on, right? We can clean this up. And, okay, let's get all our x's on one side. So subtract that, and we get 1x. And then we'll subtract 2. So we get x is equal to 3. Nice. So x is equal to 3, so that's nice. I can figure this out. So x is equal to 3, so 3 times 3 plus 2 makes this 11, and we know this is 11. So what would be the whole thing? QS would be 11 and another 11. Okay. Now, what would y be? Okay, so I figured out what x is. So remember, I can substitute that back in. Using this formula, y is equal to 1 times 3 plus 1. So y is equal to 4. Okay. Now we can double check our work. So if y is equal to 4, we could have plugged this in. 2 times 4 plus 3 is, yeah, so that I get 11, which is exactly what I wanted to get. Now let's plug this in, and I didn't even really need that because, again, I know x is 3. So 2 times 3 plus 1 is 7. All right, and again, I did solve for y. I didn't have to, but I did. 2 times 4 is 8. Take away 1 is 7. So that's 7 and that's 7. So what would be the whole blue length? PR, the whole length, would be 7 and 7 makes 14. Nice. Okay, question number 3. Find the side lengths of this parallelogram. So we know opposite sides are congruent. Okay, so opposite sides are congruent. So I have 2 short sides, they're equal to each other. And I have 2 opposite sides, but I think I can solve for x. I don't have to set those equal to each other. I think this is all I need. So let's just kind of do this one first, right? So x here is 3. So if we plug this back in, 4 times 3, take away 1. 3 times 3 plus 2. Let's check how this works. So we got 12 minus 1 is 11. We have 9 plus 2, which is also 11. So the short sides, it says find the side lengths. So here's all the side lengths. QP is 11 and RS is 11. So what about the longer lengths, these? Well, we know x is 3, right? So 7 times 3, take away 2. I get 19. Well, let's verify that's the same over here. 9 times 3, take away 8. So 27 take away 8, I get 19. So the longer sides are 19. And I've solved for all the 4 side lengths. Nice work. All right, what do they want in 4? So it says use the parallelogram below to fill in the table. All right, so again, I might need to think about each one of these as I fill in the table. It says let WY, this one, plus this one equal 30. Find this. Okay, so I'm going to call this, it says find WP. So I'm going to make X what I don't know and then solve it. But I know this is also X, right? Because these have to be equal because diagonals are bisected. So YP, or excuse me, WY plus XZ is 30. Okay. And I know WY happens to be equal to 2X. X plus X is 2X. Right? Now I know this is 6, so that means this one has to be 6. So that means the whole thing has to be 12. So XZ is 12. So now I have my formula. If I subtract 12 on both sides, right, I get X is 8, and X is what they asked me to solve for, WP. So that is 9. Now I can check this. So if this is 9 and that's 9, that's 6 and that's 6. Add them all up, you should get 30. All right, next question. It says WY, this thing, is 1.5 times XZ. That thing, find WP. So I'm going to put an X there. WY, once again, is 2X. So WY is 2X. And it's equal to 1.5 times XZ. Well, we know XZ is 6 and 6 makes 12. So we can solve for X here again. 1.5. That'd be 9. Oh, I didn't bring in my calculator. That's kind of weird. Hold on. I did get that wrong. 12 plus 6 is 18. Yeah, that'd be 18. And then I want to divide by 2. Oh, that's where I'm getting 9. All right, so I got 9 again. That's kind of cool. Now, let YP be 3X. Let YP be 3X plus 5. And XP be 2X plus 4. Find WP. So I can't use X because I'm already, so find that. Okay. Well, you know that these two, this one and this one are equal. So 2X plus 4 is 6. So we get 1. So now I can plug this in right here. 3 times 1 plus 5 is 8. So if this is 8, this will have to be 8, and that's what they've asked us to solve for. Cool. Okay, just going to erase some of these chicken scratches to give me more space here. Let 2 times WP, well, that's this whole thing. This one's 1 WP, that's a second WP. And 3 times PZ, so 2 times WP plus 3 times PZ, so that's just 6, right? Be equal to 4 times the whole thing WY. Well, what is WY? That's another 2WP. WP just WP. Okay. Find WP. Okay, so let's find WP. 2 times WP plus 18 is equal to 8 times WP. So we can subtract 2 WPs from both sides, and I get 6 WP is 18. So when I divide by 6 on both sides, I get 3. All right, one more in this section. Let's let WY be 8x minus 1. Okay, so the whole thing is 8x minus 1. All right, and xz, the whole thing, so the whole thing we know is 12. The whole thing is also 4x plus 2, but we also know it's 12 because of the 6 and the 6. So I get 2.5. So x is 2.5. Find WP. So I get the whole thing is 8x minus 1, but I know x is 2.5. So 8 times 2.5 minus 1. So what is 8 times 2.5? That's 20. Take away 1, I get 19. So the whole thing is 19. So what would be, they just want to know what's half of that. Well, half of 19 would be 9.5. Okay, wow, each of those were pretty hard. Consider the convex quads A, B, C, D. Determine if the given information in each case is sufficient to determine if ABC is a parallelogram. Okay, so let's figure out if this is going to be enough to know. So A, B, C, D. A is, I'm going to label that. A is 40, so I'm going to label the little one 40, the acute angle. B is 130. Well, oh, yeah, that's an automatic no because we said consecutive have to add up to 180, and those add up to 70. Next one, A and B add up to 180. We agree with that. And C, could C be 80? And so that would be, if C is 80, this is 80, and this would be 100, that's 100. So that would be true. That could be happening. What about, would this be a parallelogram if we said AB is equal to CD, okay, opposite sides, and BC is equal to AD? Oh, yeah. What about if we made angle B, so I'm going to redraw this last one. What if we made angle B, the smaller one? Okay, so this one's B because it's 70, it's acute. And D, okay, make D 70, okay. And then make C, so this one would be C, is 110. And I think that that would work, right? These two add up to 180, these two add up to 180, these two add up to 180, all these add up to 180. I'm going to say yes. Okay. The diagonals of a quadrilateral intersect at point K. So what do they mean by a quadrilateral? Well, essentially that's all the ones on this piece of paper. It'd be any four-sided shape. Okay, so what if the diagonals of a four-sided shape intersected at K? Which of the following is needed to prove that it is a parallelogram? So looking back here, if K is our midpoint, we know that we'd need the diagonals to bisect each other, or else it can't be a parallelogram, right? So let's see. We got a possible parallelogram, and the diagonals intersect at K. So what if DK is equal to CK? Oh, wait, that's not what I want. That won't necessarily make a parallelogram. What about if two DKs, so one DK and another DK, so that'd be that whole diagonal, is equal to DB? Well, yeah, that just means one of the diagonals bisected, but this I'm going to say not necessarily. And I'll give you an example why. If I look at my kite, notice how those are equal, but this one is not equal to that one. That one's a lot, this one is much, much longer. So that's only one set. I need both sets of diagonals. Need both diagonals to bisect. Okay, what if AK is equal to CK? Yep, that's good. We like that. But again, I'm going to have to say not necessarily because I need both diagonals to bisect. That's not enough to prove it's a parallelogram. What if ABK, so I'm going to redraw a new one. What if ABK was a right triangle? Interesting. So let's force that to happen. Let's make that a right triangle. So let's look back in our chart. What if the diagonals, what if I produce right angles? So that could also happen in a rhombus where you get right angles. That would also happen in a square. But would that necessarily give you a parallelogram? Well, again, notice my example of a kite. That would happen. But a parallelogram does not necessarily have a right angle. Notice I don't have a right angle here. So I'm going to go with no. All right, number 7. Is FGHE a parallelogram? Okay, so we're just going to figure out if these two add up to 180. And they do. Okay, and these are equal to each other. So is that going to be enough? Well, notice nothing is stopping this line. Maybe it looks parallel, but what if I exaggerated it and FE? But wait, that would mean I'm messing up this length. So, that's kind of interesting, right? So I can't do that. Well, what if E, but I have to force EH to be the same length. And then this is forced to be, that's forced to be, so yeah, and then if I go the same length here, yeah, I think that's enough to force it. So I'm going to put yes. I can't not draw a parallelogram. If these two angles are supplementary and these two lengths are the same, I'm forced to draw a parallelogram. All right, number 8. Is this a parallelogram? Wait a minute. No. I need opposite angles to be congruent, right? And they're not. They're supplementary. So this is not a parallelogram. All right, number 9. For what value of A and B is RTU a parallelogram? So if these were equal and if these were equal, that would be a parallelogram. Okay, so for A plus 3, if this is equal to this, that'd be the first step in making it a parallelogram. So let's solve. All right, and what would that do with B? So these would have to be equal. So this side, 6b minus 2, has to equal this side, 2b plus 6. There we go. And we got one more. Okay, one more. In a quadrilateral, PQRS, PS is equal to QR. If PQRS is a parallelogram, find the angle of QPS for each interior angle at the given. So if interior angle at Q is 147, you see what I'm saying? I'm picking the bigger angle. Then what is P? Well, that's just 180 minus 147. All right, and if angle Q, too much. If angle Q was 105, then angle P would be 75, right? And now I'm going to switch up the picture because I'm going to make this angle Q acute. So if angle Q was 82, what would angle P be? Right? And it's actually the same thing. It's still 180, take away 82. So 98. And here, what if it was 65? Again, same pattern. 180, take away 65. Can I check it? Yes. Just go back through and add these up, making sure they add together to make 180. Nice work, guys. See you next.